Hey guys, this is 5-7, this last thing that we're doing this week, and it's really what happens when the answers aren't obvious. What happens when the answers are imaginary? We're still dealing with this idea of producing graphs and trying to find these locations. Well, sometimes the crossing for two of them might be at something that requires a square root in the solution, something that comes from the quadratic formula. So when those happen, we have to have another approach, or at least a jumping off point for trying something different. And so today we're going to talk about what happens when. Now we still know that if we graph it and it's obvious, we're done. That's still true. We can just take the answers that are obvious and move on. But we do have to make sure we have all of the answers and that we can account for everything that's in the problem. Okay? And so, let me take a sec. Sorry, I get emails and I'm just always trying to keep up with you guys. So today we're going to talk about those different approaches and what do we do in the special cases. So there are 2 or 3 different rules that we have to deal with. 3 situations, okay? So it's the 3 things that we have to talk about, okay? One is what's called, we have square root involved answers. Meaning they're not obvious 1/2 or something like that. They will come in pairs, okay? 2 at a time. So if there's one that we can't tell, there should be 2. If you're only missing 1 0, it's something that's a fraction that's easy enough to produce by repeating the synthetic division. But if there's 2 and you can't tell what either of them is, then it's going to be square root involved, and when we get there, we'll have an approach for that. We'll talk about that problem set first. The second 2 set of problems, they don't have to happen at the same time. In this problem, we'll do them at the same time. But what happens when you have imaginary solutions? How do you find them? And again, they will be 2 at a time. They don't ever happen on their own. The fundamental theorem of algebra tells us that the number of solutions was equal to our highest exponent, our degree, but it also tells us that we can't have one imaginary solution without the other because they come from the quadratic formula, which has the plus or minus in front. And the third rule is what's called a double root, or later in our next assignment we're going to call it a multiplicity, which is what happens when the answer is repeated. What happens if x minus 2 is part of the factor twice? There are numbers like 12. If I split 12 into its smallest pieces, I get 2 times 2 times 3. Well, do you see I'm getting the same number twice? Something different is going to happen in the graph, and therefore something different is going to happen in our approach a little bit. So these 2 right here we'll see together. This will be the second problem, and this will be our first. Okay, so we're going to look at what happens in the first case, and this will be our second case that we look at today. So we're going to start out in our first case. We're going to start with x to the 4th plus 8x cubed minus 15x squared minus 146x plus 56. Okay. First thing we always do, okay, is identify how many zeros should there be. There are 4 solutions to this problem to when it equals 0, okay? Now that I know I'm looking for 4, I want to graph this. So I'm going to use Desmos today. Feel free to use other software or use your graphing calculator. It's totally acceptable. I'm on board. And we're going to look here closely at what we have as solutions. Now I'm looking for 4 of them. I can see that the green line, maybe I'll change the color of that green to black. No, that's not better. Blue. No. Red? No, purple. I don't know. I don't think it pops out very well. But anyway, we can see that it's crossing here, 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 and here. So we want to click and see if any of them are obvious. So -7, yeah, that makes sense, between -6 and -8. This one, though, see how that's a decimal? That's not a decimal I recognize. I'm going to have to use a square root to get to that answer. This is the same way. And then this one, 4, 0. So I'm going to take the ones that are obvious and I'm going to take them with me back to the homework to the notebook, which is negative 7 and positive 4. So now when I come back here from the graph, okay, negative 7, positive 4. What's really important is that I'm able to get to an x squared. See, x to the fourth has 4 solutions, but I know 2 of them. So if I take out the 2 that I know, I'll be left with x squared. That means I can use the quadratic formula to finish. So what we're going to do is we're going to set up the synthetic division, and we're going to run the synthetic division with the numbers we got from the graph, one at a time, until we get down to an x squared. So 1, 8, negative 15, negative 146, and positive 56. Now I really need this number here to be 0. So if it doesn't work right, maybe I misread something, or maybe I made a mistake with my algebra. So I'm going to use a negative 7 there as my first balancer. The first number always goes straight down. Negative 7 times 1 is negative 7. 8 and negative 7 makes 1. Negative 7 times 1 is negative 7. Negative 15, negative 7 is negative 22. Negative 7 times negative 22, holy, that's 140, 154. If you're not comfortable with that, use a calculator. I'm feeling fairly confident because I know where I'm headed. This should come out as 8, and negative 7 times 8 is negative 56. Sure enough, it gives me the 0. Boom, number negative 7 worked. I still need 3 more solutions. Well, I know that one of them is a 4, so I'm going to keep going. The first number always drops down. 1 times 4 is 4. Then I get a 5. 4 times 5 is 20. Don't forget we're supposed to have a box down here. This would be negative 2, and 4 times negative 2 is negative 8, which gives me 0 again. Perfect. This is 1x squared plus 5x minus 2. In other words, we have A, B, and C for the quadratic formula. So now all we have to do is use the quadratic formula to finish solving. If you did not get comfortable with the quadratic formula back in 4.8 in chapter 4, you're going to have to deal with it. Now, we need to start talking about it more, asking questions, going through extra problems. You'll see it on quite a few of these. I think in my notes to myself, I said that number 14 through 18, so there's 5 of them, 14 through 18, on the assignment for 5.7 are going to require the quadratic formula to finish. So I'm doing that with both of these so we can get a little extra practice. The quadratic formula is negative b, be negative 5, plus or minus the square root of b squared. That's 5 squared, which is 25, minus 4 times a, which is 1, times c, which is negative 2, all divided by 2 times a, which is 1. This is going to be negative 5 plus or minus the square root of, and I would put all this in the calculator. 25 minus 4 times 1 times negative 2 comes out to be 33. Okay? All over 2. Does 33 split into a way that has a square root? Well, 3 goes in 11 times. That's the only split. Neither one of those has a pretty square root, so I am stuck with this as 2 of my answers. If you include the 2 that you have from the graph, 4 answers. Okay? Sometimes these roots break down. It's not always that often. It just depends on the problem. The problems on the homework do break down a little bit. They should be pretty clean. But if you get stuck, check the odd answers in the back of the book or reach out to me. How is it supposed to simplify? But if you can get down to this spot right here, even if you don't simplify the root correctly, but you get to this spot, and you don't screw it up by trying something that's not legal, that's still way better than nothing. All right, let's look at our second type, and then we'll go from there. We're pretty good, pretty close here, okay? Yeah, if you need all that written down, it's called pausing the video, right? So you guys can pause the video and go back and get what you need there. All right, so the second type, we're going to be talking about imaginary solutions and a double root. So our second equation that we're going to work with is actually an x to the 5th. So it's going to be x to the 5th, which means we have 5 answers. x to the 5th plus x to the 4th minus 7x cubed plus 29x squared minus 144, x plus 180. Okay? So as we go through and want to do this, first off, we acknowledge 5 answers. The next thing we need is to graph it. So I'm going to go to Desmos. Graphing calculators work just as well, but the problem with the graphing calculator is sometimes it's hard to see. This is really nice because it's easy to pick the values correctly. All right, so here's what I see. I'm supposed to see 5 answers. I see 1 here at -5, 0, and I see 1 here at 2, 0. Where are the other 3? Now, the fact that I can't see them, you could say, oh, maybe they're off the screen. It's not going to be the case. They'll be somewhere between -10 and 10. We're not going to go crazy, although in the real world we might have bigger values. But we'd also end up using decimals. They're not going to be as pretty. This is a process for understanding the basis of the math that we do. So we're going to stay with pretty simple stuff. But, you know, we see the 2 answers. We're supposed to see 3 other ones. Well, it's very possible, very likely, that there are imaginary solutions because we can't see them. And you wouldn't see imaginary solutions anyway. So the only problem with that is imaginary solutions come in pairs, 2 at a time. So I see 2 answers. If I add 2 more for imaginary, that puts me at 4. Where's my 5th answer? Well, there's something special going on right here at 2. Do you see how instead of crossing through like it does at -5, it actually turns around and goes back up? If I graph any quadratic, like x squared minus 3, x squared gives me 2 answers. 1 here and 1 here, and they are passing through. But when it bounces, instead of passing through, we call it a double root or a multiplicity. That means this answer 2 should be counted twice because it will divide out twice. And so let's go and look at what happens when we use -5 and +2 in our synthetic division. We're going to start here by building our synthetic division. Nice long sequence. We had -5 and 2, but we're supposed to use 2 twice. So I'm going to start with -5. There's a 1, 1, -7, 29, -144. I might need a calculator, and 180. The first number always drops down. 1. -5 times 1 is -5. 1 and -5 is -4. -5 times -1, -4, sorry, is a +20. That gives me 13. -5 times 13 is -65. Now I want to make sure I don't mess this up, so I'm going to grab my calculator and get 29. Oops, turn it on. 29, and it's plus a -65, so it's like -65. That's -36. Times the -5 would be positive. I think that's 180. And -144 plus 180 is a 36. And -5 times 36 is -180, giving me my 0. Have to have 0 in the corner when we're doing finding zeros. So I'm going to run the next number, which would be a 2. Run the 1. 2 times 1 is 2. -4 and 2 is -2. 2 times -2 is -4. That makes 9 times 2 is 18. -36 plus 18 is -18. 2 times -18 is -36. And there's my 0. Now, because 2 is a double root, or what we call a multiplicity, we get to reuse it. It's not a one-off throwaway. We're going to reuse it. So now I get a 1. 2 times 1 is 2. We get 0 there. That's not where I need 0. I need 0 over here. 2 times 0 is 0. 9 and 0 is 9. 2 times 9 is 18. And there's the 0 I need. Now keep in mind, we were at x to the 5th. Then we were at x to the 4th. Then we were at x to the 3rd. Now we are at x squared. We have a, b, and c for the quadratic formula. All right, almost done. Quadratic formula is -b. Well, -0, that's weird, but it's fine. Plus or minus the square root of b squared. 0 times 0 is 0. Don't fight it, just use it. Minus 4 times a is 1 times c is 9 all over 2 times 1, which is 2. That gives me 0 plus or minus. That's not going to matter, so I'm just going to drop the 0. That thing doesn't make any difference. So plus or minus square root of, let the calculator do the work for us. It comes out negative 36 all over 2. Well, the square root of 36 is a number. I know the square root of 36. So this is plus or minus 6, but that negative gives me an I. Guys, we were expecting imaginary answers, so we should expect right here to have imaginary answers. And that's over 2. That simplifies to plus or minus 3i. That's 2 answers, 3, 4, 5 answers. Should be everything. There's going to be problems that throw you off. Let's talk about them. But you've got to try them. Use the calculator to find the obvious solutions, and then dig your way through the others. But you've got to get stuck before we can talk about why you're stuck. You've got to start the problem. So let me know where you need help. I hope to see you in class as often as we can. Good luck.